So this is assignment number 1 in our new unit, Unit 4, which is on linear equations. And this particular assignment is on a constant rate of change, which we will call the slope. And so we're going to look at constant rates of change or slopes like given a table. Sometimes we're going to look at them given 2 points or a graph, excuse me, or even an equation. And that's what we're going to be focusing on during this video. So let's start with some tables. We can see here that we're going to find the constant rate of change, which we also call the slope, for these situations. And the first situation is an example of a babysitter. We're going to jump from one table to the next, or one value to the next. So it looks like to here, she is babysitting for 4 hours. She went from 2 hours to 4 hours, but she's getting paid an extra $10. She was paid $16 to babysit 2 hours, but to babysit for 4 hours, she got paid $26. That's $10 more over a period of 2 hours. Well, then she babysat 5 hours and got paid how much more? Well, 26 to 31 is another $5. So she was paid $5 for 1 hour. Then maybe she babysat another time for 7 hours and got paid $10 more than when she babysat for 5 hours, because 31 plus 10 is 41 for 2 hours more of work. Well, how much is that every hour? Well, the first example, she worked 10 hours, or she got paid $10 for 2 hours of work. 10 divided by 2 is 5. She worked here 5 hours. She got paid $5 for 1 hour extra of work. That's $5 per hour. Then here, for 10 extra dollars, for 2 extra hours of babysitting, she got paid $10 extra. And if we divide 10 divided by 2, that's also $5 per hour. So the slope for number 1 is $5 per hour. That's what she gets paid every hour in that chart. Now, if we go on to number 2, you can see the answer down below. But here, number of hours or number of weeks that go by and Jill's weight. So Jill must be on a diet, and over a period of 2 weeks, from her first week to her third week, so that's 2 weeks, she lost, it looks like, 6 pounds. Well, how much is that per week? Well, we waited 6 weeks. She measured her weight again. It looks like she went from 145 to 136. She lost 9 pounds in 3 weeks. And then we waited 4 weeks. So in 10 weeks, she went from 136 to 124. That's a loss of 12 pounds in 4 weeks. Well, how much is that per week? -6 divided by 2, that's -3 pounds per week. -9 divided by 3, that's -3 pounds per week. And then 124 divided by 4, or -12 divided by 4, that's -3 pounds per week. So her slope is that she's losing 3 pounds per week. So it's a constant rate of change that's going on in the table, and that is what we call the slope. So let's move on to something like this. Here they're just given an x and a y. Instead of putting it in a table, we could have put it in a table. We could have said this is, here's x and here's y. So when x is 2, y is 7, but then when x is 5, y is 13. And it looks like when x went up by 3, y went up by 6. So just like we did in the previous slide, where we divided the y values divided by the x values, we're going to do the same thing here. We're going to take the y value divided by the x value, that's 6 divided by 2, which means the slope here is 2. Now, there's another way of thinking about that, and that is, instead of putting this in a chart like this, we got 6 here because we took 13 minus 5. 13 minus 7. So that's 13 minus 7. That's the 6. And then on the bottom, we got the 3 because we took 5 minus 2. 5 minus 2 is 3. That's 5 minus 2, which is 3. And then 6 divided by 3 is a slope of 2. So we're kind of using this equation, or this form right here, to find the slope. Let's do the same thing here. If I did this with an x and y table, then I would have negative 3 is matched up with 6, negative 1 is matched up with negative 2, but I would find the difference here. I would take negative 2 minus 6, which is negative 8, so it went down 8, and then from negative 3 to negative 1, it actually went up 2. Negative 1 minus negative 3 is actually positive 2. So it's negative 8 divided by positive 2, which gives me a slope of negative 4. But I could think about it like this. To get the negative 8, well, that's negative 2 minus 6. Negative 2 minus 6 gives me negative 8. And then 1 minus negative 3, or negative 1 minus negative 3, that's the same thing as negative 1 plus 3, which is positive 2. And so I'm taking this number minus this number on top over this number minus this number on the bottom. Well, here's what that looks like. To find the slope given 2 points, if I call those points x1, y1, and the second point I call it x2, y2, well then I can find my slope by using this equation. I could take y2 minus y1, that's what I have up here, y2 minus y1 over x2 minus x1. And that general formula will always give me my slope if I know what the 2 points are. So let's take a look and see how this looks like with a graph. So if I'm going to start, let's say, with this graph right here, let's say I'm going to go from this point here to this point here. The first point is 1, 5. So I have an x value and a y value, and it's 1, 5. And I'm going to this point, which is 2, 8. 2, 8. So again, from 5 to 8, I go up 3. From 1 to 2, I go up 1. So if I take 3 divided by 1, well, that gives me 3. And the slope here is 3. I could do it by taking these numbers and subtracting them. I have a point at, let me do it down here. I have a point at 1, 5. That's a 5. And another point at 2, 8. So I could find the slope by taking 8 minus 5 over 2 minus 1. 8 minus 5 is 3, 2 minus 1 is 1, and my slope is 3. So there's another way I could do it. Or I could do it like this. To go from one point to the next, I could think of it as, how am I changing? Every time I move one space to the right, it looks like I'm going up 3 units, which means the slope is 3. So every time I move one space to the right, I'm up 3 units. Same thing here, except this time when I move one space to the right, I go down 2 units. So the slope here is negative 2. I could do this with points. I could identify points just like I did over here and use the formula y2 minus y1 over x2 minus x1. I could make a table of values and see how the y changes and divide it by how the x changes. Or I could just do the rise. In this case, the rise is negative 2, and the run, you'll hear me say that a lot, the rise over the run. The rise is how far it goes up and down. The run is how far it goes over. So in this particular case, the rise is negative 2, the run is positive 1, and negative 2 divided by 1 is negative 2. So in a nutshell, how do we find the slope if we're given a graph? Well, if we're given a graph, we can simply use what is called the rise over the run, which is this right here. And how that works is, if I have a graph, and let's say it goes through this point here, and it also goes through this point here. If I want to find the slope of this line, it looks like it goes up 1, 2, so it goes up 2, and then it goes over 1, 2, 3. So the slope here is going to be 2/3. It goes up 2 every time it goes over 3. What that means is every time I go over 1, it goes up 2/3. I go over 1, it goes up 2/3. If I go over 1, it goes another up 2/3. So we can apply that to situations like these graphs. If I do rise over run here for number 7, I'm going to start with this point, and I'm going to go, let's say, to this point right here. So that means I'm going to go down from 160 to 120. That's down 40, and I'm going to go over from 0 to 1. So the slope is negative 40, and I label it always with my y over my x. And so this is miles here and hours here. So this is negative 40 miles per hour. Miles per hour. And so it looks like he must start out 160 miles away from his destination, but then as time goes by, he's subtracting that distance by negative 40 miles every hour that he travels. If I do the same thing here with number 8, let's say I pick this point here and I pick this point here. I'm going to go up from 3 to 5, that's up 2, and I'm going to go over from 1 to 4, that's a distance of 3. So the slope is positive 2/3. And if I label it, it's 2/3, it's y per x, so it's centimeters per day. So really don't know what this is talking about, but maybe it is a plant that is growing, and it's growing 2/3 of a centimeter every day. So that means every day that goes by, it grows up 2/3 of a centimeter. Now, if it was shrinking, it'd actually be a line that looks like this, that's going downhill. If it's not growing at all, the slope is 0. It's just staying constant. And so when we look at this slide right here, we have a line that looks like this, which is a positive slope here. It's going uphill. Every time we go over, it goes up something. That's positive. It could be a slope of 0 where it's not changing. If this was a plant, it's just staying the same height the whole way across, so it's not growing. That's a slope of 0. It could be a slope that's negative, which means whatever it is, it's getting smaller as time goes by. And so it's because it's getting smaller, the slope would be like a -1 or a -2 or even a -1/2. Or it could be a line that looks like this, that's perfectly straight up and down, and that's just an undefined slope because it's not changing at all. It can't move from right to left. And so the slope tells us how is it changing every time we move from right to left. And so we're going to have positive slopes which go up to the right, like this one, negative slopes which go down to the right, 0 slopes which go directly straight to the right, and then these slopes which are perfectly straight up and down, which have no slope at all. And that's today's lesson. Good luck on your homework assignment, and we'll see you tomorrow in class.